Okay. Hey, everybody. While this is coming up, sorry I'm not there today. I'm obviously major bummed because I love this lesson. I think this lesson is so cool. But, oh well, I'll talk about it tomorrow. And I'm getting to teach it right now. It's like, great. And then I get to have it all for all time because I'm going to save it on YouTube. Okay, so first things first, why don't you guys get out your homework? I'm going to go through the homework and then I'll just go through the notes. I would definitely, don't worry about this homework quiz thing. I'm just going to delete that page. I would definitely take a lot of notes in this section, pause a lot, write everything down. This is one of those sections where like it might not sink in right now, but it might sink in later. Okay. So first things first, get out your homework, start checking your answers there. I'm just going to, scroll through, pause where you need to. Okay. There you go. Good. Okay. If you have any questions on that homework, I will answer those tomorrow. It's probably pretty good, but I just wanted to throw that out there. If you need any questions, by all means. All right. So section 4.2, multiplying matrices. Remember yesterday we introduced what is a matrix. A matrix is just like a rectangular set of numbers. If you've used a spreadsheet, you've used matrices. If you used Google Sheets, you've used matrices. So now what we're going to do is operate with them. The first one that we did was addition. Remember, addition had that rule of matrices had to have the exact same dimensions to be able to add or subtract them. And then we had a scalar multiplication as well. We didn't talk about matrix multiplication just quite yet. That's what we're going to do today. But scalar product was just basically distributing a number to the entire matrix. Okay, so let's talk about matrix product or multiplying matrices. Here are the rules. Ooh, that looks like a lot of rules. Okay. To multiply two matrices, if you would like to multiply two matrices, they have to have the product of two or more matrices, the matrix product, obviously. Following rules apply. Okay. Definitely write down these guys. Yes. Matrices A and B can be multiplied only if the number of columns in A equals the number of rows in B. The number of columns in A matches the number of rows in B. Okay, so like if A was an M by N matrix, A is an M by N, and B was an N by P matrix, right? Do we all notice how those two values are the same? That means that we can multiply these two matrices. Only if those values are the same can we multiply those two matrices. So what happens? Well, it's kind of like, remember the transitive property from last year, like how it linked the two middle things together? That's kind of like the same thing here. Not really. I don't know why I think about it, because the solution, like the product A, B, will be an M by P matrix, okay? Oops, I forgot my little X in there. M by P matrix. This number by this number, this rows, this columns, okay? All right, so those are the rules. Take a look here. Just going to give you some examples and non-examples, okay? So like A times B, a 2 by 3 times a 3 by 4, it will work. The matrix product will be a 2 by 4 matrix. C, look, C is a 3 by 2, 3 rows, 2 columns. Or sorry, yeah, 3 rows, 2 columns. The D is 3 rows, 5 columns. Notice how these numbers don't match. I can't multiply them, okay? So let's practice if we can multiply or not. Okay? If we can possibly multiply. So a 3 by 4 times a 4 by 2. 3 by 4 times a 4 by 2. Good. This we can multiply together, right? This one works. Yay. So the result is a 3 by 2 matrix. Yeah. We don't know how to make it yet, but we know it's going to be a 3 by 2. Is this doable? 1 by 4 times a 3 by 4. Is that possible? No, not possible. Yeah. Can I point something out here in A? We said that A times B was possible. Would B times A be possible? Because, you know, A times B is possible. We said it would be a 3 by 2. But is B times A, like, so if I change the order of these numbers, will it change the outcome? Like that was that whole commutative property, right? If I change order, does it change outcome? Well, let's see. Will it change outcome? Is B times A even possible? 4 by 2 times a 3 by 4? What? It's not even possible? Oh, that's awkward. That's weird, right? So this isn't even possible. A times B is possible, but B times A is not possible. Like we've learned our whole lives that like if I've got like 5 times 2, it's the same thing as 2 times 5, right? So within matrices, this property doesn't hold. What? What? Oh, no. Okay, yeah, we'll talk about that later. All right, so this next slide may be overwhelming. It's going to be okay. Take a moment. Pause here, please. Write down this whole box. I know it's going to seem really weird. I know. Just relax. It's okay. All right. So hopefully we're pausing here. I'll give you a moment to pause, and whenever you got it written down, play again. All right. In a matrix product, okay, in any matrix product, P is equal to A times B, where A and B meet the requirements to be able to multiply them, right? Each element of the product, okay, each element of, so P is the product of A times B. Each element of the product, lowercase p, ij, notice what this means. If I do a lowercase, that means I'm talking about the address here. Whatever entry in P, say the address was ij, where I and j are just dimensions in P, each element, each entry, is the sum of the products. Okay, sum. I'm going to add up the products. I'm going to add up all the multiplications of consecutive entries. Okay, so of like matching entries in row I of matrix A. So whatever the first number is, I'm going to take that row out of the first matrix. Oh, I'm sorry, that's my cat. In row I in matrix A, and column J in matrix B. Column J, second number is the column number out of matrix B. Okay, so take a look at what we have here. I'm going to use my highlighter a lot this class here. Okay, so say I have a 2 by 2 times a 2 by 2. Obviously, I can multiply them, right? A 2 by 2 times a 2 by 2 is going to yield another 2 by 2. Take a look at, say, this entry in the product. What's the address here? Well, the address is really easy. It's just 1, 1. It's easy. Sorry, my cat is all up in my face. So this entry is 1, 1, right? 1, 1, P 1, 1, row 1, column 1. That means I'm going to take row 1 out of the first matrix, column 1 out of the second matrix. And I'm going to multiply corresponding entries. So like the 1 and the 5 get multiplied together. The 2 and the 7 get multiplied together. And then I add up the products. I add up the product. 1 times 5 plus 2 times 7, that'd be 5 plus 14, that'd be 19, right? So the final, obviously I can evaluate this out, but it would be 19, right? Okay, so what if I had said, I don't know, this entry? Well, this is P22, right? Row 2, column 2. Row 2, oh, that's going to stick together, really? Yeah. Okay. Row 2, okay, I'm going to have to erase you, dude. Sorry, buddy. So long. Row 2, column 2. 3 times 6 plus 4 times 8. I multiply the corresponding entries together, and then I add whatever I get, okay? So it all depends on the location in the product the address and the location in the product will tell you which row and column to use out of my first and second matrices. All right, let's do this. Okay, so my first thing that I want to check is it possible? W is a 3-row, 2-column matrix. X is a 2-row, 3-column matrix. Is this possible? Yep. Maybe it's not a smiley face, because if it's not possible, you could stop here. Maybe I should be making it the other way around. Like, this is a frowny face that we have to do all this work now. All right. So here's what I want. Now, again, my solution is going to be a 3x3, right? I take this, it's a 3x3. So here's what I always do. I always write out a big matrix with all of my like blank spots in it. Like, I'm going to create myself a little spreadsheet here of all of my answers, right? A 3x3 matrix is 3 rows, 3 columns each, okay? And now I go in and I say, okay, I am going to find each entry out of that product. Here's my solution. I'm going to find each entry out of that product. Okay, I'm going to pick at random here. Say I wanted this entry. Okay, say I wanted this entry. In the solution, it is row 2, column 1. Row 2, column 1. That's this entry, right? So I am going to go in and I am going to choose row 2 out of my first matrix, column 1 out of my second matrix. Okay, row 2, column 1, row 2, column 1, row 2, column 1. Now I'm gonna multiply corresponding entries. 1 times 4 is 4. 0 times 5 is 0. So it's 4 plus 0, right? 0 times 5 is 0. 4 plus 0. That's my answer. That's this entry, just this entry. Okay, so say I wanted, I don't know, let's move around here. Let's do, I don't know, well, this guy. Yeah, this is row 3, column 2. Row 3, column 2. Row 3, column 2. Okay, so now I say row 3, column 2. 2 times 7 is 14. 14 and negative 1 times 1 is negative 1. 14 plus negative 1 is 13. Okay, so here's what I'd like you to do at this point. I've done 2 out of the 9 entries. I would like you to pause and fill out the rest of the matrix by yourself. Do this, really do this, because if you don't practice this stuff, you're going to struggle with it. You need to practice it. You need to actually work through it. Okay, so really, really pause, and I'll pick up here in a second. Okay, so I'm going to work my way around. Whoa, don't move 13. Row 1, column 1. Row 1, column 1. Okay, so that's 12 and negative 10, right? 12 and negative 10. 12 and negative 10 make 2, right? Okay. Over here, row 1, column 2. 21 and negative 2, so 19. Okay. Row 1, oops, don't move 19. Don't move 19. Don't move 19. Thank you. Row 1, column 3. Okay, so this is negative 6 and positive 2, right? Negative 6, positive 2. Negative 6 plus 2, negative 4. I should really check my answers here. I'm really sorry if I screwed this up. I mean, it's past 9. I have this rule, it's like, if it's like before 8 in the morning, I can make a mistake. If it's after 9 at night, I still can make a mistake. So we'll see. Hopefully I don't make a mistake. Okay, this is row 2, column 2. Row 2, column 2. 7 and, ooh, I like when there's a 0. 7 plus 0 is 7. Okay, this guy is row 2, column 3. Negative 2 plus 0. Negative 2. Okay, this is row 3, column 1. These guys. So this gives me 8 and negative 5. That seems like a 3. Okay. 8 and negative 5. Yep. Sorry, just double checking. And this last one, 3, 3. This gives me a negative 4 and a positive 1. So negative 3. Okay. And there we have it. That's matrix products by hand. Okay. All right. So 2 stores held sales on their videos and DVDs with prices as shown. Use the sales data to determine how much money each store brought in from the sale on Saturday. All right. So basically what I'm going to do is I'm going to use a matrix product to find the sales of each store on each given day. So let's take the dimensions. This is a 2 by 2, 2 rows, 3 columns. This is a 2 by 3. The only way I can multiply these together, I hope we see this, I can't take this matrix times this matrix. This would be a 2 by 3 times a 2 by 2, and that does not work. The only way I can multiply these together is take the 2 by 2 times the 2 by 3. Right? 2 by 2 times the 2 by 3 would be a 2 by 3 matrix, right? So that means 2 rows, 3 columns. 2 rows, 3 columns. 1, 2, 3. 1, 2, 3. Right? All right, so let's go in, and I'm going to pull up my calculator here because I don't know these. Maybe got messy decimals on here. All right. Okay, so 2 rows, 3 columns. I'm going to go through and I'm going to say, okay, what is my entry each time, right? What is this entry? This is 1, 1. Okay, so that means, again, I'm going to give out my highlighters here. Row 1, column 1. Okay, so that is 895 times 23 plus 1195 times 40. 683.85. 683.85. 683.85. 683.85. Get out of my way. 683.85. 683.85. Okay. You all see that? 895 times 23 plus 1195 times 40. Okay. So now let's just keep going across. Oops. Whoa, what? What the what? What the what? Okay, we're back. So now let's just keep going. Let's just keep going across the top here. Yeah. Row 1, column 2. Row 1, column 2. This guy right here. I'm not going to use this circle anymore. Okay, so let's go back to my calculator. That's 895 times 31 plus 1195 times 48. 851.05. 851.05. 851.05. Okay. And now this guy is row 1, column 3. Okay. So now I'm going to go back to my calculator and I'm going to do 895 times 25 plus 1195 times 42. 725.65. 725.65. Again, sorry if I punched something in wrong. And then I do that same whole process, but now this guy. Okay? Because this is row 2, column 1. Okay, so I'm going to go back here, and I'm going to do 7.5 times 23 plus 12.5 times 40. 672.50. 672.50. And I do the same thing here. I do now this guy. Whoa! Whoa! Stop it. Thank you. I'm going to go back in here. I'm going to do 7.5 times 31 plus 12.5 times 48. 832.50. And again, please be doing this along with me. What did I say? 832.50? Yeah. And then lastly here, this guy or girl, right? That's what Clevenger's saying in his head. Or girl. All right, 7.5 times 25 plus 12.5 times 42. 7.5 times 25 plus 712.5. 712.5. 712.50. Okay, so now this is my new matrix. Now, what the heck do these numbers mean, right? Well, think about it. You know, if I wanted to apply the labels back again, what did I use? Well, where did this 2 come from? This 2 came from this guy right here, right? So this was the number of rows out of this matrix. So if it's if I use the number of rows, I'm going to use the labels of rows. This is at Video World, and this is at Star Movies. That's supposed to be a star, by the way. Yikes. I used the columns out of this guy to make my matrix, right? So I'm going to use the column labels here. Friday, Saturday, Sunday. Okay. Now, I don't know if we caught it, but they did ask me a question. Use the sales data to determine how much money each store brought in from the sale on Saturday. Video World brought in $851.05. Star Movies brought in $832.5 or $832.50. Okay. All right, let's keep it moving. Okay, so because square matrices can be multiplied by themselves any number of times, you can actually find powers of square matrices, and you can only find powers of square matrices. Like, think about it. What is the only dimension that can be multiplied by itself, right? Like, can I multiply a 2 by 3 times a 2 by 3? No, that doesn't work, right? What the what? Stop it. Think about it. What matrices can work like that? Well, only square matrices. A square meaning, obviously, it has the same dimensions, rows and columns, like a 2 by 2 or a 3 by 3 or a 4 by 4, because the rows and columns have to match, because when I multiply, the rows and columns will have to match. Okay, so only square matrices can do this. Well, what do I get if I multiply 2 by 2 times a 2 by 2? Another 2 by 2. What if I get if I multiply 3 by 3 times a 3 by 3? Another 3 by 3. So it keeps yielding me more 2 by 2s and more 3 by 3s and more 4 by 4s. So if I take a 2 by 2 times a 2 by 2 times a 2 by 2 times a 2 by 2, I keep getting 2 by 2s. So I can take the powers to third power, fourth power, fifth power, right? So take a look here, p to the third. Now, I will warn you, way too many people try to do this, right? Don't do this and like distribute that power in. That makes me do this. Yeah, don't do that. Don't do that. No, mean face. Okay. So what do we do then, right? Well, you do matrix products. You basically do this. 4203, 4203, 4, oops, 4, I said 4 and I wrote 2. Yikes. Yes, this is getting late for me, folks. 4203. Okay. So we take it piece by piece here. What is this? Well, think about it. It's not just 16, right? You can't just multiply corresponding entries. This is row 1, column 1. This is 16 plus 0. Well, coincidentally, it does just come out to be 16, but that's coincidental because this guy's a 0, right? What is this? This is row 1, column 2. Row 1, column 2. 4 times 0 is 0. 0 times 3 is 0. Boop. Row 2, column 3. Row 2, 3. What? Jeez, oh Pete. Row 2, column 1. Row 2, column 1. So this is 8 and 6. 14, right? 2 times 4 is 8. 3 times 2 is 6. 14. This is row 2, column 2. Row 2, column 2. 2 times 0 is 0. 3 times 3 is 9. Okay. then we have to multiply this again, right? So that's going to get me another 2 by 2. Row 1, column 1, right? Row 1, column 1. 16 times 4, 64, plus 0 times 2 is 0. Row 1, column 2. Row 1, column 2. 16 times 0 is 0. 0 times 3 is 0. Row 2, column 1. Row 2, column 1. Okay, so now I got to go back in here because I don't know that offhand. 14 times 4 plus, so row 2, column 1. 14 times 4 plus 9 times 2, or 18. Whoops, I'm getting ahead of myself. 9 times 2. I wrote 18. 9 times 18. 74. Okay. And then row 2, column 2. 14 times 0 is 0. 9 times 3 is 27. Right? So it may look like I raise it to the third power, but I don't. Yeah, I can't just distribute that power. This is actually what p to the third would be like. The only reason it looks even close to raising it to the third power is because it's got a 0 on it. All right. Hopefully we had as much fun as I did. See ya.